I'd like to now thank RWDI, one of our sponsors, and invite Mike Williams, Principal Sustainability at RWDI, to come forward and introduce our closing keynote speakers. Mike, come on up.
Thanks very much, Larry. Wonderful. I'll keep this quick because I'm standing between you and the big show and then the wine and cheese, so that's a lot of... You don't want to be hearing from me. But I did want to introduce Russell. Russell Acton is an architect, founding partner of Acton Ostry Architects, which began practice in 1992. Their work has been recognized with over 90 awards. Many of these projects featured wood. I had the chance to give Russell a call before the event, and we had a really nice chat. Very, very humble and approachable person. One thing was clear from our conversation: he is very passionate about building with wood, which I think really fits with the theme of the conference here and all the other bits and pieces that have been coming out of this. I think wood has a lot of potential. So I shared with Russell that there is a lot of buzz in the building design and construction community in Ontario right now around wood structures. And so a lot of leading sustainable developments are thinking about building with wood. And so my question for Russell was, is this just a fad, or is it a long-term trend that we're actually going to start to build with wood? And I thought this was actually a really poke and prod question, but he answered immediately and said, it is just a fad right now, and we have a lot of work to do to make it a trend. And so we need to revisit codes, and we need to share a lot of knowledge, both within the design community, within the construction community. We still have a lot to learn before we're really going to make this thing take off. So with this idea of knowledge, I think it's a good segue into bringing Russell up on stage to share his knowledge. And I think we're all going to learn a lot from his talk, and really looking forward to it. So without any further ado, here's Russell.
I'll do a quick technology transfer here. Great. Okay, well, thanks very much. I have to say is that this is my first Green Building Festival, and I've really been impressed and pretty blown away, frankly, by everything that I've been learning and being exposed to. And now I'm just feeling like I'm just doing this kind of like a little piece of sustainability, green kind of talk, and I think it's an interesting and important one in terms of the potential for mass wood in the future. And so my presentation's titled "Extraordinarily Ordinary Mass Wood for the Masses," and that's because the project I'm going to speak about, Brock Commons, is exactly that. It's extraordinarily ordinary. Brock Commons is it's an 18-story, 53-meter-high, 404-bed student residence that recently completed construction out at the UBC Point Grey campus in Vancouver. And this project really went through an ordinary process. It went from concept to construction in just 10 months' time. It was required to just fit into the typical development cycle for student residences, concrete student residences out at UBC. But the cool thing about this project was that during the summer of 2016, over just a 9-week period, that Brock Commons became the tallest contemporary mass wood building in the world. And we think demonstrated that mass wood buildings have far-reaching environmental benefits. So here's what I'm going to talk about, and I'm going to begin by outlining the challenge that UBC set for the project. It's very key to what we're looking to achieve. Then I'll go over some design, technical, and construction considerations, and then I'll conclude with a summary of the sustainability benefits that I think that mass wood structures offer for the future development of cities. And then after that, if there's some time, be happy to answer any questions, hear any comments, or we could do that probably better over some wine. So And of course, before moving on, I just need to acknowledge, I can't name them all and talk about them, but I had a really amazing, highly collaborative team. UBC put them together, put us all together, and really that was the key for the success of Brock Commons. It's going to be the key to success for subsequent, significant mass wood tall buildings. And this team, it included a tall wood advisor, Herman Kaufman from Austria, engineering and specialty consultants, the construction manager, a BIM and virtual construction specialist, and representatives and suppliers from the construction industry. So onto the challenge, and with this challenge, our goal was to just keep it simple. The genesis of this project was that back in 2013, National Resources Canada issued an expression of interest to Canadian developers, institutions, and organizations that were willing to design and build high-rise wood demonstration projects. The idea was that National Resources Canada would provide funding support with the objective to identify potential building projects that would safely and successfully demonstrate the use of wood as a viable structural system in buildings of 10 stories or more, with the goal of pushing the boundaries of structural wood products and ultimately expanding upon the opportunity for new market development. So you see it's very, very focused. It's all about the wood. I was fortunate to be invited as an evaluator for the Tallwood Demonstrations Projects Initiative, so I was part of a committee of 8 that reviewed a number of submissions, and we wound up advising and recommending financial support for Brock Commons at UBC and the 13-story Origine project in Quebec City, presently under construction. And then late in 2014, we were really fortunate, went through the selection process for architects for Brock Commons through UBC, and we were awarded the project. So again, let's talk about the goals and objectives that were outlined by UBC in their expression of interest. And I think the key to our success was we focused on what they were interested in achieving without imposing like our special interests on that. So the project was to address the strong demand for on-campus housing. There are about 4,000 or 5,000 units short of the demand. The housing would be for upper year and graduate students. There'd be about 400 beds. Very key, UBC wanted an advanced wood-based building system to be used with the goal of demonstrating the applicability of wood for BC's development and construction industries. So again, it's a focus about the market and the use of the resources in BC and advancing them. The project was also to be monitored and evaluated to provide reference knowledge to support future changes to the National Building Code. We were to achieve a minimum of LEED Gold certification. And the construction budget was $30 million for approximately 157,000 square feet of buildable area. And finally, it was stated that if it was not viable to build with mass wood, that would be okay, because that would just be a conclusion of a due process, and so then the project just wouldn't go ahead in wood. But the university had built 18-story concrete slab student residences. They've done 4 or 5 before Brock Commons, and so they would just build another one of those. So like I like to say, no pressure, no pressure at all. So this is an excerpt from an email back in August of 2014 when we were deciding whether we would even pursue the project. And even back then, before we'd even submitted our response to the EOI, our thinking was to develop an approach that would lessen problems rather than create them. Put a bunch of architects and engineers together, and invariably they make things much more complex than they really need to be. We felt that a hybrid structure with concrete components was the way to go. We've just seen on projects around the world that they seem to be more favored by the approvals authorities. And even here you can see in here, even though we thought that some exposed wood might be nice, we recognize that the schedule cost, fire protection, and acoustical considerations would have to take precedence over the aesthetics. This was underscored by this very, very tight construction budget we were given, which at the time worked out to only $191 per square foot. But a quick study, we knew this was lowballed. we knew it was actually lowballed to just drive down the fees. It wound up coming in at about $235 a square foot versus a comparable concrete student residence would have been, say, about $210. So $235, pretty impressive number. And I've been at a few Masswood presentations, and no one ever, we're the first ones I've ever heard that ever talks about the cost, and that's because we're proud of the cost. Everyone else's costs that I hear behind the scenes, it's twice that or more. So the message was clear. Brock Commons was to be constructed for an ordinary construction budget. And I like to think that, it turned out that we pretty much nailed it with our strategic approach. It turned out to be exactly what it would take to design and deliver this tallest Masswood building in the world at this much lower cost than any other before it. But unfortunately, I don't really anticipate that this is going to be equaled or beat for quite some time. And that's because when I look around at tallwood projects, they're luxury towers. There's one in Amsterdam. I think that's like a single unit per floor. It's going to cost a fortune, and there's others too. I think that we're really missing the focus, which is to get a lot of these built instead of a few showpieces here and there. And our thinking was really in alignment with that of our Tallwood advisor, Herman Kaufman. He was the architect for the Tallwood LCT1 tower that was completed in 2012 in Austria. So Herman acted in the capacity of a Tallwood advisor when he shared his philosophy for Tallwood during 2 early design workshops that were held at UBC. As you can see, as Herman likes to say, Tallwood is not about promoting a vision, but rather about fueling an evolution, with the main objective being to continue taking precise and consistent steps. And that's because that's something that Herman's followed that through his entire career as he's brought Passive House forward through advancements where he just tweaks it one or two moves each time. So Herman really recognizes that the evolution of tallwood buildings is in its infancy, and that it's over time that these small advances will lead to those big changes. And for Brock Commons, designing and delivering an extraordinary Masswood building at the cost of an ordinary building would be a huge step forward for tallwood buildings worldwide. So we began the design process by taking a look around the tallwood landscape at the time. And most of what we saw were visionary projects that had 2 things in common. One, they were all towering edifices, and none of them had got built. But when we researched precedent projects that had actually been built, we noticed they were quite different from the visionary ones. They were relatively short, modest, residential buildings. They were background buildings. The 9-story Stat House in London, completed in 2009, and the 10-story Forte in Melbourne, completed in 2012. At that time, that was the tallest wood building in the world. And from the outside, you can see these buildings, they don't particularly look like they were built of wood. And from the inside, they pretty much look like regular market housing buildings with white gypsum walls and hardwood floors. And these tallwood buildings appeared to us to look quite ordinary, which would prove to be quite influential. So with all that in mind, we chose to accept a UBC challenge for what it was and to approach the design of the project accordingly. And that's because we realized to make an impact on the mass wood movement, there must be meaningful use of mass wood. It must become commonplace and ubiquitous. Mass wood buildings must not continue to just be these one-off isolated showpieces. They must become a genuine option and a preferred choice for developers and builders. And they must become affordable to design and to build. And to be truly environmentally meaningful, mass wood structures must be incorporated into buildings of all types and sizes, whether the wood is exposed or not. And so Brock Commons aspires to be a model for mass wood of the commonplace, the affordable, and really the buildable. And so Brock Commons aspires to be a genuine game changer of extraordinarily ordinary mass wood buildings for the masses. So in terms of design, again, you're going to see this over and over. Keep it simple. So Brock Commons is located in the campus core district of the University of British Columbia. Even though it shows up as a green site on there, there was a bunch of temporary classroom portables that had to be removed. You can see they didn't give us much of a site, right beside a parkade. And when I say not much of a site, I mean physically it wasn't much of a site, in that the building didn't even fit on the site. We had to take over a bit of the roadway there. There used to be straight-in perpendicular parking across the street there. So we centered the building roughly on the adjacent parkade, provided public open space to the east and a raised terrace to the west as an amenity for the students. Here's the ground floor plan, and it includes social and study spaces for the students that live on the building over on the left. And over on the right, there's social and amenity spaces for students that live off campus. So their collegium, their home away from home, place to study, meet their friends. And then there's support spaces at the back there, mechanical, electrical, waste and recycling. And it's up here on the main floor because there's no basement. We went through this study and analysis, and the client just couldn't think of why they really needed to go to the time and expense of constructing a basement. At the request of the structural engineer, again, we're looking for our guidance from the structural engineer, not imposing a form on him. The typical floor plan has a symmetrical layout with two equally sized concrete cores. That's because we used a slip form system, two-story hall, a tall one that just went back and forth between the cores to optimize the construction. You can see on the plan, there's quad units. They bookend a series of studio units for a total of 24 beds per floor. You can see you can't get much more rational than this plan, and the client was great on that. You know, we would just, every time that there was a decision to be made about making something simple, everyone bought into it. So the form and massing features a rhythm of vertical striations with a CLT canopy at the base and a cornice crown up at the top. There's a view of the public realm and the main entry to the student residence. And this section shows an extensive 58-meter long CLT canopy that runs along the front of the building, and you're getting a view here into the social and amenity space for the students. There's a view into the quad units at each end of the floor plate. And up at the top, we used one of these quad units on the 18th floor where, because the building code allows it, we exposed the structure there just for demonstration purposes. On to some technical considerations, and again, just the overriding approach was to keep it simple. And in terms of the challenge, I have to say the most important challenge was securing an approval from the provincial authority to actually build the project. And this was the handout at the first meeting I attended with the provincial authority about the process they wanted us to go through to assure them that this project was meeting their standards, which required that we had to obtain a site-specific regulation from them, and a site-specific regulation specifies what requirements in the building code wouldn't apply, and then it replaces them with substitute requirements. But rather than following this long and winding path envisioned by the authority, our approach was just to make the process as simple and as direct as possible. And I think we kind of surprised them on that. They're not used to that, I think. But they did want to complicate things by requiring that we present the project to 2 expert panels comprised of a mere 20 experts on each panel, 1 expert panel for fire and the other for structure, and their role was to advise the authority whether the technical risks for the project were deemed acceptable. So again, our strategy was to make it simple for the authority to grant approval by seeking approval for just 3 items. And the first was use of a masswood structure in a high-rise application. The second was encapsulation of the wood structure to achieve the required fire protection ratings. And the third was use of an exposed CLT canopy, which actually we didn't have to ask. We just thought it would be nice to ask them because we were sprinklering it anyway, and so it's permitted by code, but we thought they might be worried about it because of the wood up above. So really the key thing here was that it was for reasons of cost, fire protection, and the approvals process. We had a very, very tight constraint on this, was that the wood structure would be encapsulated with gypsum board completely to achieve that approval. And the schedule did not permit time for any testing of new fire assemblies. So this is why we had to rely on known fire protection systems and the qualities of gypsum board. Even though we had a thicker than required CLT slab, for example, where we could have taken advantage of some char in our calculations, but we didn't want to confuse the authority. And this strategy was very successful as the province issued the site-specific regulation just 3 months after our presentation to the expert advisory panel. And that's certainly, they admitted, that's a record. And so we used a hybrid structural system, concrete, wood, and steel. The first level and the 2 cores are concrete, above which are 17 floors of the wood columns and CLT panels. Steel drag straps are used to transfer the seismic forces from the CLT to the concrete cores. And the roof structure is made of steel, and that was on the recommendation of the building envelope consultant. We had originally designed it in wood, but they advised the client for a belt and suspenders kind of insurance policy, I guess, that if it was steel, there couldn't be any slow leaks. They said, roofing membranes, they fail over time, and you just don't know it, and they were concerned about if a wood one would have been susceptible to some leaks of the membrane. The wood structure is made up of a variety of components. The panels measure 2.85 meters wide by 6, 8, 10, and 12 meters in length. We used parallel strand lumber columns down at levels 2 through 4 at the central locations, just because of the higher capacity, structural capacity required. But the typical glulams are 265 by 265 millimeters from levels 2 through 9, and then they reduce in size to 265 by 215. This is the location of the primary steel drag straps that are just screwed to the top of the CLT for the transfer into the concrete cores. And this is a perimeter steel angle that stiffens the CLT and supports a prefab facade envelope that we applied to the building. And I guess this is the second innovation point for the project. So a key feature of this mass wood structure is that no beams are required, and that's due to the use of a 2-way span CLT flat plate slab. And this had never been done before. Been used in really, really small applications on CLT projects, but not for a complete floor plate. And the beauty of this, with having no beams, is then you can distribute the services, very efficiently. If you have to go through beams or under beams, that's a big problem. The other thing is the height limitation. This building is 53 meters tall because that's the maximum height permitted at the university. And before we had come up with this two-way span system, we could only fit 17 floors in there. And that's a big economical concern, because we would have had to take up more land, and it would have actually not been seen as a positive in terms of the fact that they were getting concrete student residences up at 18 stories on there. So we're happy when FastNet came up with this great idea. And these panels were tested out of the FP Innovations Lab at UBC, and because they were a bit of an unknown, they had an idea of what their structural capacity would be, but it turned out that they actually wound up having 25% greater capacity. And that's just because no one had taken a look at this before. No one had tested this kind of a system. And this is the steel connector detail that got developed. It's really simple, practical, and economical. The connectors are epoxied onto the glulam columns, and then holes in the CLT panels are guided onto 4 threaded steel rods. The base connector is then slid into the upper connector and then fastened with just 1 steel pin. Then a steel cover plate's added, and the panels are bolted into place. And these manufacturing and erection tolerances are very, very tight. They're just plus or minus 2 millimeters for both the columns and the panels, and they need to be positioned within the same 2 millimeter tolerance. I should say we actually did develop an all-wood solution for this, but it meant that the columns needed to be a bit bigger in order to support the CLT with the shearing, and there was concerns about the ability to achieve the fire protection required. But we think that there's a solution there for the future. So here's a view through the connection after it's assembled. Again, very, very simple. And this shows the final finished assembly after it's all been fitted out. So on to construction, again, keeping it simple. Back in July 2015, full-scale 2-story proof of structural concept mock-up was constructed to test the various interfaces between the CLT slabs and the glulam columns, for example, as wood-to-wood connections I'm talking about, and then also obtain feedback from the installer on the erection process. And the details were modified in response to the feedback that was provided. So I said we didn't have to do a testing of the assembly. However, we were required to do testing for the fire stop penetrations through the CLT, because there's just not a lot of information available on that. So we carried out this test using copper pipe, cast iron, and PEX piping. And the fire stop was required to provide 90 minutes of protection, but we ran this test for 2 hours, and there was still full protection. And the reason why we did it for 2 hours, because again, we didn't have this official test, but so we wanted to do this unofficial one. And after 2 hours, the result was we only had a slight loss of gypsum board with 0 to 1/4 inch of char at the CLT. As I say, built into this thing was like 29 extra millimeters of wood that we couldn't use to rely on char. When we were at the expert panel, I remember the fire science consultant asked one of the guys at the NRC what he thought that this assembly would test out at, and he thought 4 to 5 hours. So it's very, very redundant. It's all about getting the approval and getting this mass wood building built so there can be improvements on it in the future. We also did mock-ups of the prefab facade. And here you can see them being installed on a steel framework where there's testing for building movement tolerances and weather tightness were performed. Prefab facades in Vancouver don't really happen, so this was kind of a first again. Prefab panels, we had to do a lot of work with the prefab supplier when they were first doing some testing of this. It was taking them about 50 minutes per panel to install it. They had to change their system and then got it down to less than 10 minutes per panel, and even faster than that once it's positioned in place. So the glulam columns and CLT panels were manufactured in BC by Structurelam. And as I mentioned, Brock Commons was virtually constructed numerous times to assess the constructability and optimization of the design and construction processes. So the digital model, it wasn't simply an expression of the design, it was a simulation of the construction methodology. And that's why you're seeing all of the course of construction elements included. And this video shows just a few of the steps followed for forming that freestanding 18-story concrete core, which I have to say is an achievement in itself. It's never been done before out in Vancouver. So you see here, every component was assigned a specific location on the deck, and every step of the process was optimized for speed as well as safety. And during construction, the videos were viewed on cell phones by their workers to ensure that the proper process was followed. And this video shows the optimal sequencing for the wood structure and the facade. The glulams are placed on the deck in bundles, and then the columns are braced. Additional CLT deck and glulam columns are erected, and then the facade's craned and fastened into place, and this just repeats itself over and over and over again. And here's the virtual made real. So it just takes 6 to 12 minutes to install each CLT panel. That includes the lifting and travel time by crane. And you see the site looks really quiet, and that's because it was quiet. There's only 9 workers needed to erect the mass wood structure. That's a 9,200 square foot floor plate. Special care was taken with the first level of the wood columns on the concrete transfer slab to ensure they were precisely installed within that 2 millimeter tolerance. You got to get it right. Can't correct afterwards. It's one of those first 12-meter CLT panels being raised into position. Here you can see the high-strength Paralam columns that were centrally located on the lower floors. Here the panels are being guided by the workers onto the threaded rods of the steel connector and also over the HSS piece of the connector. And up here you always got to have a sledgehammer handy in the course of construction. It's just giving the panels a tap just to ensure they're sitting tight on the steel connector below before they're bolted into place. On the deck there you can also see some plywood splines. They were used to join the CLT panels together through a combination of nails and screws. Just a nice view of that sexy CLT panel being raised against this backdrop of prefab facade panels. And here are some CLT panels being installed on the 16th floor. The columns were temporarily braced to lock them precisely in position. Just the exact plus or minus 2 millimeter designed. You can see it's just a bit of aluminum angle fixed to a 2x4 to just make sure that it's in the correct tolerance. And then before each panel is brought into place, those braces are systematically removed, and then the CLT panel is dropped, and then it just locks the system tight again. Here you can see the guys just again getting it precisely located and dropped. Here I like this one. This shows me good old Canadian know-how, high tech meets low tech with the glulam columns. They just got these guys to just heave them up, drop them into the steel connectors. There's that guy, he's got the tough job. He's got to bend down and put that steel pin in place and walk away and go on to the next one. And this is that completed connection. This just gives you a view of the repeating rhythm of the installation system. Another view. This was installed at a rate of 2 levels per week, including the prefab facade. The team felt that they could do 3 floors. 3 floors per week is achievable for this size floor plate. You just have to work Saturdays, I think they said. Not unusual. Here's a panorama of just one of the floors with the CLT panel installation in progress. And here's one that's finished. And you can see how clean and clear this working level is. There's no waste or debris present, and that's because there's no waste or debris made. No one had to sweep this or clean this up. It's just what you see is what you get. Here's the prefab facade being manufactured in a plant just outside of Vancouver. There's 22 separate jigs distributed over the floor area because, of course, we had 22 separate panels. And just a 6-man crew just takes 8 hours to install the prefab facade panels for each floor. And you can see up top, you can see the steel angle, the panels hooked over that steel angle, and you see the little steel pins down below. It's just dropped onto the steel pins, and that's just all it takes. And here's just a video showing that process. I've cut out 6 minutes of walking that panel around the back of the building here, but they're just aligning it over the steel pins, making sure that it's hooked over the steel angle, and then just dropping it into place, and then they can permanently fix it at their leisure. This is an interior view. You can see the little square plates. That's what they're using at the base to hook onto the steel angle. So I found that showing the progress of this erection process in 1 week increments really emphasizes the speed of construction. So during week 1, only 1 level was installed as this time was taken to ensure everything was precisely positioned. And at week 2, the pace had picked up to the 2 levels per week. By week 3, we're up to level 7, and 2 stories of the facade were installed. And here we are, end of week 4, we're up to level 8, and I just like to say, this is the equivalent of erecting a 6-story building in just 1 month. There's tons of 6-story buildings, and you could have that plus the facade in just 1 month. By week 5, we're over the halfway point. Week 6, we're up to level 12, 14. At week 7, ends in sight. Week 8, and then here we are, 18th level, week 9. That's 66 calendar days with only 46 masswood installation days from start to finish. And then the next day, the installation of the steel roof structure got underway, and ironically, the steel work went a bit slowly, and that was because they had a hard time meeting the high precision of the wood down below. These images show the interior progress at the time that the wood structure was completed, again back 11th August 2016. So you can see levels 18 and 17, there's no facade installed yet, but it is from their downward, and at level 16 downward you can see the facade. 15, 14, and 13 had the concrete topping installed. I should point out the concrete topping is only there for acoustical purposes. It's not about fire protection, it's just acoustics. Levels 12 and 11 had a single layer of gypsum installed at the underside of the CLT, and level 10 had 3 layers of gypsum installed, and that was what we needed to get the fire protection without counting in the wood. And here, this dash yellow line, this represents the level to which a concrete building would have reached with a similar 9-week time frame. But the key difference being that at least 4 floor levels below would be filled with temporary shoring, there would be no building envelope, and no other work would have taken place. But now back to the mass timber progress. Levels 9 had the gypsum installed, and levels 8 and 7 had the columns encapsulated. And down at 6 and 5, the conduit and ductwork had begun, and levels 4 and 3, the plumbing was underway. And partitioning was underway at level 2. And down at level 1, at the concrete structure, partitioning was underway, and the main electrical and mechanical spaces were very much well underway. And so this was the state of construction after the steel roof had been completed and the uppermost prefab facade panels had been installed. And in many, many respects, the exterior appearance didn't change much until completion of the project, and that's because the majority of the work was taking place in the interior. And here's the completed building. These photos were just taken. They're not even officially released, so you're getting a sneak peek. Couldn't resist. Southwest view showing the elevator cores. This is the northwest corner, and you can see the cornice crown up above. This is the building base with the CLT canopies. The entry to the student study and amenity space. And here, this is the main student residence entrance with a good view of the prefab facade above. Okay, now when I say extraordinarily ordinary, we're going into the interior. This is the circulation space. This just looks like any of their other, well, frankly, I think it looks better than their other student residences. This Trespa panel that we clad the building with, 70% wood fiber in it, was a big decision maker in that one. There was no breakage at all in shipping, so we had so much product left over that we wound up cladding the elevator core with it all the way up. Off in the distance, you can see an entry to one of the quad units. Before we get into quads, this is the student studio unit. Very, very modest. It's 245 square feet in area. And a view back, you can see they get a full kitchen and some storage, and there's a washroom back in that door you can see to the side. This is the quad unit, the view of the living space with this literally, I'm going to say multi-million-dollar Vancouver view. You can see two of the bedrooms off in the distance. I don't think it's very hard to imagine, even with this tight grid that we're using, of imagining this being used in a market housing application. Here's the view back the other way with the kitchen, and you can see a little glimpse of the bedrooms that finish off the quad unit beyond. And this is one of those bedrooms. I always wonder what students won the lottery here for the distribution of the housing. It's a pretty sweet view. And then now on to sustainability. And again, because I'm just an architect, I'm going to really strive to keep it simple because I usually have others describe that for me. But I'm going to start it off by showing this short time-lapse video. It's produced by Naturally Wood. They're promoters of BC forestry products. Whole host of information on their website about Brock Commons. And I've slowed this video. It's a 2-minute video, but it's going to take 3 minutes of your life here to watch it. I've slowed it down to 3/4 speed because I want you to see what does and doesn't happen on the site during construction of a mass wood building, because that's really, really telling. Just how calm and clean and quiet, like the neighbors remarked on this. It's almost like they didn't notice this 18-story building going up. So we're in week 1. As you can see, you just follow along with the data, just 9 workers, but pay attention to that ground plane. You can see, we got like one bin there, and you'll just see things, just panels and prefab facades just constantly get brought in the same space. Just very, very little waste in transportation on the site. Already at week 3. So I've mentioned the size of the columns there, but again, before the camera's going to tilt up, so again, enjoy that lack of intrusion on the site down below. Here we are at that that kind of that 1 month point where you can see just how amazingly quick this progress is using a prefab system with such tight tolerances. You'll see every now and then, off to the left, a concrete pump truck kind of sneaks in there to put the topping down. There it is, making a guest appearance there. 29 CLT panels per floor. You can see 5-ply, 169 millimeter thick. As I said, in Europe, this we were considering Austrian supply of the material. They would have provided a 140 millimeter two-way slab system that would have been performing the same structural task. The reason why ours is thicker is because we get our lambs from the 2x4 industry, and so it costs money to reduce their size to slim down the panel. Structure Lambs told me actually since then they found a supplier that's willing to provide them a thinner lamb. So yeah, of course, that there's the choice of construction products has a significant impact on the environment. I think that goes without saying. And here's a few of those facts and figures regarding the estimated environmental benefits due to mass wood. I'm not going to read them. You can glance over them. But really of particular note is the amount of the carbon stored in the wood and the production of greenhouse gas emissions that has been avoided. And in this case, with Brock Commons, we're realizing a total potential carbon benefit of over 2,400 metric tons of CO2. And here, these are what I like to call the stealthy sustainability benefits that are supplementary spin-offs to the use of mass wood structures. I mean, in terms of for the impact that developers and builders are going to enjoy just by using this system. And I got to say, it's like this construction manager who, this is their only tall wood building they built. Their business is building concrete high-rises. While this system was going up, they just had smiles on their faces, and I'm not kidding, because it's the first time they've seen something different in the construction industry in decades. And I'm not kidding, they were literally weeping about going back to concrete. They've seen the future, and they like it. And the only thing that they're sad about is it's still going to take 3 more years in BC for the code to change to where they're going to be able to get more opportunities to build these buildings. So again, just looking at these, all of these benefits save money. They save time, they save energy for the builder and the developer, and that's why they're going to want to do it. We all know, there's not a lot of motivation, unfortunately, for doing good to the earth. But it's these stealthy sustainability benefits that I think is going to really lead to builders and developers wanting to use mass wood just because it's fast, and it's fast because it's accurate with this these tight tolerances. There's way less waste. Recycling is just 94% they were hitting on site here, and it's just quiet. The neighbors are happy, and that's big in the development world. I got to say, it's huge in Vancouver. It's just ridiculous. Nobody wants anything happening in their backyard, and if we can cut the time down in half and then enclose buildings and fit them out afterwards, that's going to be a big selling point. Trucking way reduced, which again, it's cleaner in the neighborhood, it's quieter. Just everything is just such a huge benefit, and so all of these things that the developer and builder gets, well. And then we get that carbon sequestering and that renewable resource. Just like, it's an added benefit, and I think that's the cool thing. You don't even have to sell it on that merit. You sell it on the merit of the constructability and the economics. So from a LEED perspective, Brock Commons was required to achieve LEED Gold certification. We had the painful experience, you'll see I'm not a LEED fan, of using version 4, the sustainability office at UBC, made us use it a year before it got officially released, and so we had a very tough time finding products that would meet the criteria, because guess what? Nobody had to deal with them yet. So this was the LEED scorecard back in July. You see, back then we're on target with just barely with 62 points, but it's recently been updated to 67, so we're comfortable there. And then as a point of interest and personal aggravation for me, the use of a mass wood structure earned us a single innovation credit. But that was offset because we're losing a point because even though Structure Lam has been supplying FSC wood since 2006, there was a paperwork snafu by the builder, and so, lead takes it away because you can't prove that Structure Lamb didn't go and, I guess, chop down some trees without following good sustainability practices. Thanks, lead. I appreciate that. So in terms of ASHRAE, the project was required to meet ASHRAE 90.1 2010. These are just what the university assigned for the project. We actually used a prescriptive path compliance method, and that was because we were well under 40% glazing, somewhere in the mid-30s, might even have been 33, sorry, I've forgotten. The UBC Sustainability Office set a building energy target of 135 kilowatt hours per meter squared per year. And that was just based upon similar buildings, these concrete student residences. So there was no focus on reducing that. And that's because, again, this was a fairly single-minded focus for this project was, could we do it in mass wood? The ground level spaces are heated and cooled with an air handling unit that's connected to the UBC district energy system, and then the hot water is heated by the district energy system, but heating for the suites is provided by electric baseboard heaters, and they have an auto shut off when the windows are opened. This is the makeup of the prefab assembly. It was steel stud framing. It was a competitive process. There was a wood frame proponent and actually a concrete sandwich panel proponent. They were both more expensive than the steel stud framing one. Again, it's about the money. This is literally, UBC looks at this as a development project, as well they should. I mean, that's why the challenge is here. And then some exterior grade drywall with a liquid applied membrane, thermally broken supports, Cascadia clips, double glazed windows, just crummy double glazed aluminum frames. We couldn't afford the good fiberglass ones. Took a look at it, but didn't fit the budget. Mineral wool insulation, about 50 millimeters out there, and then these Trespa, the wood fiber laminate panels. And then afterwards, we did actually insulate the cavity with bad insulation, applied a vapor barrier, and then type X drywall inside. And the R value for this whole thing, 16.7. We did a quick study about if we could get it up to passive house. We could add 2 more inches of insulation, but the economic model didn't work. Energy is so cheap at UBC, and the way that their operating costs are provided, or funding is provided by the government, like they would have to rethink the system, and they just don't like to rethink the system. This diagram shows the development of structural systems over time. I think it's kind of an interesting one. Concrete and steel, you can see, are mature systems. They've been through this process of innovation, development, and resolution. They've been around, almost forever, for contemporary construction. So they've had time to optimize and refine a whole host of products with well-established and known design and construction parameters. There's little room really left for innovation and reduction of costs. It's just as the resources go down, they become more and more expensive. And you can see Masswood there, it's just the little guy there. He's just kind of starting this climb up that hill of innovation, only really been introduced there. And so there's still a lot of time to develop, grow, and mature to achieve comparable resolution of the optimal design, product and construction considerations, and the optimization of cost. I mean, as each Masswood project is constructed, it's obsolete. I mean, we already know that we would do Brock Commons different if, with changes that have happened out there. Also, with respect to building codes, concrete and steel enjoy a whole host of prescriptive design and construction solutions because they're already embedded and recognized in the approvals process, and Masswood has a long way to go to catch up. But interestingly, through our work with Brock Commons, the BC authorities have told me that they're developing 2 paths for approvals of Masswood structures in the future. And the first is going to be kind of a straightforward, prescriptive, it'll be tested solutions, ULC for encapsulated mass wood. Origine did a test of their system with 1 layer of gypsum board, and they got a 2-hour rating. We had 3 just to handle the politics to get the project approved. So we were always confident there's going to be improvements for this. So as I wrap things up, I just want to return to Herman Kaufman's tall wood philosophy and emphasize that tall wood isn't about promoting this, this vision. It's really about fueling this evolution. And the main objective, I really believe, is to continue to take these precise and consistent steps and to really nurture the development of mass wood as it grows and matures. And that's because if you propose anything greater than that, there'll be too many heads will explode. And so really you need to crawl before you walk, and you got to walk before you run. And I have to say is unfortunately many of the mass wood projects that I see being promoted around the world seem to be more about sensationalism than about substance. Imagine just say, 18 stories and below, if in our cities that those were all mass wood structures. I mean, that's a hell of a contribution to the carbon sequestering issue. If we got 1/3 of buildings in cities were built with mass wood, that'd be really incredible. I mean, in terms of the sensationalism, I mean, do we really need another Empire State Building, but built out of wood this time? No, we need these mid-rises and lower. That's where the quantity and the volume is. So let's not lose sight that the development and growth of mass wood has a long way to go. But I think it's going to be these simple, straightforward, extraordinarily ordinary mass wood buildings that's going to be the foundation upon which mass wood will make a genuine and meaningful contribution to the future sustainability of our cities. And we've certainly been really pleased with the huge response Brock Commons has received internationally, really highlighting our message that mass wood can and should be used for all types of buildings. And yes, that does even include those audacious ones, but most importantly, the everyday ones. And if you were to read only 2 articles on Brock Commons, I'd really highly recommend these 2. The February 2017 issue of Canadian Architect, it really brilliantly captured the complex issues that surround mass wood structures of today and where their evolution may lead. And the March 2000 issue of Firefighting in Canada, I know you all have your subscriptions, but it really astutely expresses the change in perception that firefighters are experiencing as they learn more about mass wood structures. I mean, man, you can't buy that. Look at that quote from John McKierney, the Vancouver fire chief, that this, Brock Commons, one of the safest buildings in the city. So in conclusion from Brock Commons, well, we've learned a lot, but what we've really learned is that mass wood is fast. It's fast and accurate. As I said, it took only 66 days to erect and enclose 17 stories of wood structure. Mass wood is clean. There's virtually no waste produced during its erection on site. And mass wood is quiet. Man, I can't tell you how big this is. The only sound of note is that of a crane and screw guns. There's just no jackhammering or coring activities taking place. No metal shoring being dismantled and rattled about. The truck traffic is significantly less noise there. And then the majority of this construction activity to finish off the project is contained within the building envelope, again, muffling the noise and the disruption in the neighborhood. And of course, mass wood's sustainable. Canadian and U.S. forests replenished the wood used at Brock Commons in just 6 minutes. And the project realized a carbon benefit of over 2,400 metric tons of greenhouse gas emissions avoided. And mass wood, well, it is economical and it's going to be more economical. As I said, this preliminary cost comparison indicates that the construction cost is within about 8 to 9% of a comparable concrete building. We've got all of these first-time costs, but price parity is within reach. But to get there, mass wood needs competition. The market needs more mass wood suppliers and related product support industries. I was showing all these products that they have available to them in Europe. We just don't have any of that here. Well, we do. We just got to pay. We got to pay for all of that shipping and for those nice, sexy, expensive systems. But having the United States entering the mass wood market should prove to be extremely significant in the future when they figure out that there's money to be made there and the benefits for construction. And then finally, mass wood needs approvals. The building codes need to include mass wood for high-rise applications. And really, there's absolutely no doubt in my mind that in a not too distant future, our cities will feature extraordinarily ordinary mass wood for the masses, and that's simply because mass wood buildings make sense. Thank you.
A couple of questions between Russell and a glass of wine. Anybody got them? Could I ask you to come up to a microphone, please?
Can I
Got one over here.
I guess it's going to be, as this is taking off, a massive sort of tug and pull between the concrete industry and the wood industry, as it has been with the steel industry and everything else. So there's going to be, it's going to be an ongoing thing. But you're an architect and a highly respected one, and I'm curious, and the virtues of wood you've definitely, with the 5 advantages are clear, and I don't know enough you know a lot, way more about it than I do. So they're very, very credible points of view. But I'm curious about yourself as an architect, whether or not it wouldn't be a better thing if that industry actually incorporated some kind of fire inhibiting system within it. Because wouldn't you agree as an architect that this building looks incredible without all this drywall in it? You know what I mean? It would be remarkable, and then as you slide these walls in, if there's drywall on those walls, fine, but you have got these beautiful wooden ceilings and this and that. So that would be a huge advancement. So I think they're not done with their work. I think the work to make it as a building is totally on your shoulders, which I think is too bad. The other thing about it is that I've worked with precast and everything else. I'm wondering to what extent the job has become enormous on your office's shoulder to actually allow those tolerances that have to be, as you're saying, like Core Slab does the same thing, within 2 millimeters, which is of course phenomenal, reviews on shop drawings and everything else, and then of course on site and everything. I'm just curious in terms of the practice of architecture about that. And then my last question is...
You're going to have to repeat them because I'm having a tough time remembering the first one. Yeah.
This is a slip form construction view of this building. Like it's totally inspired by concrete construction. And wouldn't you agree that to have it be really interesting from more perspective than concrete versus wood, if that would lend itself to a type construction which released you from this sort of straitjacket of concrete construction?
Okay, well, I'll start with the first one because I love that question because I love answering it. It's like, no, this wood looks like crap.
Oh,
this is utility grade CLT,
Oh.
and that's so that we can afford. That's all we can afford to use, and there's a huge advantage to encapsulating this CLT. First of all, I have to say, I can't tell you how many times I'd be on tours with other architects and developers going, "Oh, Russell, you must be sad to enclose it." Well, no, actually, I wasn't. It was never the objective or the point. I have to say is that when I also hear that, I always think that architects like to say that, but I'll tell you, man, if you take your mom up there or something like that and say, "Hey, would you like to live in this wood environment?" They'd run screaming. For those of you old enough to remember Twin Peaks and how David Lynch kind of used too much wood as kind of like a creepy, ominous kind of like weird setting, I mean, seriously, I think there's something to be said. That's why I start this with what is selling out there and what's being developed. It's white walls and it's wood floors. If the market wanted wood, developers would be finishing their products completely paneled. Nobody wants that. Nobody wants that. They want a white wall so they can paint it pink if they want, or blue, or if they can put fake stone on it, or a mirror. It doesn't matter. So I think that's actually really, really missing the point. And also, sure, we could have upgraded everything to architectural grade, which to me, even then, it kind of has the feeling of a community center. It's not very sexy. Bernard Gaffner from Fast and Ep, he was a structural engineer. He's Swiss. We're talking about the idea of exposed wood and how it gets promoted, that then you have to lovingly protect this, this product that is just like, that costs money. That costs money. It's going to get damaged. I'm just telling you, it's going to get damaged. Then you have to repair it. Then you have to, use kid gloves around the whole thing. He says in Europe, if we're doing CLT and then we want to have a nice wood wall, well, we put paneling up afterwards because it just makes sense, I mean, not everybody. He's talking about more sort of market kind of driven projects. Herman Kaufman does these beautiful CLT exposed systems, but they're not cheap. They're not cheap. So no, I'm not sad about it at all. I got to tell you, I'd love to work on an exposed mass wood building, but it's a completely different problem to solve, and I would just love to do that, but that's not this problem. So it's really losing sight. This is all about economy. You're asking about systems, calling this a concrete system. Well, no, actually, I'm going to disagree. It's a wood system. It's going up, rapid fire. It's better than concrete. It's going up. We didn't use, say, CLT walls, for example. Herman told us he couldn't. Last time he did a CLT wall project was in 2005. That's because he couldn't afford the CLT on any of his projects. Make no mistake about it, wood is expensive, and high quality, high grade wood is even more expensive. My understanding is like with Andrew Waugh Thistleton for their projects in London, they're able to use CLT, because there's a huge, there's just a difference in terms of the carbons, the carbon sequestering kind of focus as opposed to what we have here, I think. So there's that, but also it's really built, their projects are built on land with challenging subsoil conditions, where they're also grounded 2 floors of additional height, so they're building more product, so they're getting more return, so they can afford to use those CLT walls. So it's I got to say, it's all about the money. It's just all about the money, and I think that a lot of people in the room here, I heard a couple of presentations where they were saying that it's really about that. There's limited groups and interests and clients that will do it to help save the planet, especially if it costs more. So.
We'll take one more, and then we can have additional questions out in the foyer there.
Yeah, I'll be happy to rant out there too.
All right.
Okay, Russell, first of all, thank you very much for that, and I'm appreciating the tone with which you're delivering your presentation about the mass wood for the masses. One of the things I was wondering if you could talk just a little bit more about is a bit about the approvals process and how you pushed it. Yeah. So just, some key stories.
Yeah, I mean,
appreciate it.
Those guys, how do you define conservative? Wow. It was a startling process of just seeing how, although they come to the table, they've got their directive from above that they got to make this work, but they're not happy about it. They weren't happy about it. What they were happy about was how we made it so easy for them. And then I have to say, so I'm just going to say is that was it. It was actually a pretty smooth process because we made it easy for them. But what we did was we set the groundwork to make them think now that that they're developing their code, their future code, and I think that it is quite clever. I was actually surprised when I was talking to the guy on the phone. He was telling me that they're going to do these 2 tracks because they make complete sense. So really, I think encapsulation is going to be the economical solution, and I think exposed is going to be the expensive solution, and we'll see that for high-profile projects. It's just going to be the same as what we see with exposed concrete projects. They cost a bomb, and with wood. So long way to go with government, but I think that they're they're at the table and they're wanting to make changes, albeit a bit slowly and conservatively.
All right. Thank you, Russell.
Thank you. My pleasure.
All right.